Hi guys, welcome back to YouTube channel Chemistry Live UGPG. So today we'll discuss concept of Bent rule. So this will be highly beneficial for BSc Chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So this is the syllabus Core 1 Unit 4 Chemical Bonding. So today we'll discuss the concept of Bent rule. So it is the preference of atoms having different electronegativity to occupy the hybrid orbitals which are non-equivalents. So that is having different S character and different P character. The central atom involved hybrid orbitals with higher S character has higher covalence and less S character in the bond with higher ionic character. So higher electronegative substituents prefer hybrid orbitals of the central atom with greater p character and less s character. Similarly, lower electronegative substituents prefer hybrid orbitals of the central atom with greater s character and less p character. So this is the example PCl3F2. So according to BSPR theory, number of bond pairs in this molecule will be equal to 5 and lone pair equal to 0. So the structure should be trigonal bipyramidal, and here are the arrangements A, B and C. So since electronegativity of fluorine greater than chlorine, so F atoms in structure C will occupy the axial position, not the equatorial position. And so the correct structure is C. So let's talk about the energetics of hybridization and the concept of bent rule. So hybridization is the concept of mixing atomic orbitals into new hybrid orbitals with different energies, shapes, etc. than the component atomic orbitals. So when a set of hybrid orbitals is constructed by a linear combination of atomic orbitals, the energy of resulting hybrids is a weighted average of energies of the participating atomic orbitals. So this energy of hybridization is of the order of magnitude of bond energies and can be important in determining the structure of molecules. So the bent rule encompasses the relationship between the bond polarity, that is the ligand electronegativity, and the central atom geometry through their mutual connection to central atom hybridization. So according to hybridization, atomic orbitals combine and redistribute their energies to form hybrid orbital. And these are identical with respect to energies, shape, etc. And the shape of hybrid orbital depend upon the contribution of s and p orbitals, and it affects the energy of hybridization. So Bent rule states that atomic s character tends to concentrate in orbitals that are directed towards electropositive groups, and atomic p character tends to concentrate in orbitals that are directed towards electronegative groups. So usually s orbital has lower energy than p orbital, and more s character decreases the energy of a bonding orbital and hence have shaped like a s orbital. Similarly, more p character increase the energy of a bonding orbitals and hence have s shaped more like p orbital. So s orbital is more closer to the nucleus, so it stabilizes the lone pair. Due to more s character, so less repulsion and less hybridization energy and less bond angle. Vice versa is true for more p character. So the most stable arrangement would be to utilize the pure p orbitals for bonding and letting the lone pair into pure s orbital. So s orbital is more penetrating and the electron density is less available for bonding. So thus more electronegative atoms would be able to withdraw more electron density from p orbitals than from s orbital. So Bent rule says the more electronegative substituent prefer the hybrid orbital having less s character, and the more electropositive substituent prefer hybrid orbitals having more s character. So this is the concept. More electronegative substituent prefer the hybrid orbital having less s character, and more electropositive substituent prefer the hybrid orbital having more s character. So example, the sp3d hybridization in PClX F5 minus x. So in sp3d hybridization, one s orbital, 3 p orbital and 1 d orbital form 5 sp3d hybridized orbital. So all these 5 hybridized orbital are not the same type. So they can be divided into two non-equivalent sets. So the first set is known as equatorial set of orbital, and it is formed from one s orbital and one px orbital and one py orbital. Similarly, the second set is known as axial set, and it is formed from one pz orbital and one d orbital. And it is experimentally found that the more electronegative substituent occupies the axial position, as it has less s character, that is F, and less electronegative substituent is equatorially substituted, that is chlorine. So here is the structure, so accurate structure. So these fluorine atoms will occupy the axial position, and these three chlorine atoms will occupy the equatorial position. Similarly, the less bond angle in CS2F2 also is explained. So in case of sp3 hybridization, the methane or carbon tetrachloride form tetrahedral geometry with bond angle 109.28 minutes. But in case of CS2F2, the FCF bond angle is less, and it can be explained by Bendt's rule. So fluorine is the more electronegative than hydrogen, so FCF S character is less than 25%, while HCH it is more than 25%. So due to less S character, the bond angle is less in CS2F2. So please subscribe to our channel Chemistry Live UGPG. This is also available in the website www.chemistryliveuGPG.com. For class 11th and 12th, this is the channel Foundation Chemistry AV. So this is a simple step towards e-learning, making life better. Thank you all for learning.